what are your general thoughts on
Yeah.
quantum consciousness ideas? This is Penrose and Hameroff,
Yeah.
of course.
Yeah. There are many more. I looked into, I would say, the largest part of that in very great detail.
Yeah,
I'm like, to a certain extent, my work course in physics and mathematics was quantum foundations of quantum theory.
you're
And
the
now I'm
right
in
man to
consciousness,
ask.
so
So
how can I not? And
yeah,
I think so in general, the situation isn't great. The
okay,
situation is this, that we have maybe 20 different theories. Penrose Hameroff is just one, of how quantum could be relevant to consciousness. And first problem is that just the state, the rigor of the research is not very high at present. These are things like the Penrose Hameroff theory. I'm sure Stuart will, if he listens to this, he will probably shoot me an email and explain, how all of
he's
what I'm
so
now going to
adamant on
say,
X. He's
it's
constantly just going
yeah,
after people, being like,
yeah,
"Orc theory is
yeah,
the only one that
yeah,
works." Constantly
yeah,
just going. He's a bit
yeah,
aggressive on X.
yeah.
I have to say, I'd love
It
to
is,
speak
it
to
is
him,
true, unfortunately,
but he
yes.
is a little
But
aggressive. Yeah,
I'm happy to learn more. So I tried
yeah.
to discuss this before with him. So this is not entirely idiosyncratic, but I'm happy to learn more. But I will say this. So for example, Oko are basically the only explanandum it targets, the only thing it really can explain are when conscious experiences occur. Right? It doesn't explain the content of consciousness. It doesn't have a Toy Story for the content. It cannot explain the stimulus threshold conditions. Like, why do you see the stimulus now and you didn't see it earlier? It doesn't explain it doesn't give you the structure of conscious experience, right? For all of these, I have some thoughts of how you could probably mess around with the theories to try to get that. But at the present, it doesn't explain so much. It explains everything that people were supposed to explain in the paradigm in the field when Stewart made the theory, or Stewart and Penrose made the theory, right? We had this binary paradigm. It was fine to explain this binary paradigm. Therefore, the theory was good. But we've now, at least the younger folks in the field, have moved on, and
Yeah.
we have new paradigms, and we want people to explain more. And yeah, this is one example. And then other examples are there's problems with, people often equate observers with consciousness, which is problematic. People, there's this idea that
What are the differences? Maybe that's
yeah.
worth just disentangling a bit, because I would even
Mm-hmm.
conflate them quite a lot. What's the
Mm-hmm.
difference between an observer and consciousness in that case?
Yeah, that's a good question. So my point would be like these are two different concepts, and if you want to equate them, you have to have good reasons. And here's one good reason, and that is a good reason that von Neumann already had. So much of the problems of modern quantum theory, many of the problems come from one single thought, and the thought is that isn't everything quantum? Like it's basically this idea. Well, like I'm measuring the quantum system, but the measurement apparatus is just supposed to be the same sort of thing as what I'm measuring. So it should also be quantum. And I agree, and you can play this game and you can think, like, I mean, we're like this reductionist view in physics. You can say, well, isn't everything, we have the theory about the smallest part. Isn't everything just the smallest part? Evan Thompson and co-authors, they call it smallism, Isn't everything just made out of these small things? And I think when you have this thought, and then you look at quantum theory and you realize, look, there are two different dynamics for basically small and big things. That's a little bit sort of a simplification. So there are two dynamics, one for what the quantum system does, and second for what happens if you actually bring in a measurement device or an observer, right? So you immediately have this whole measurement problem. You say there are two dynamics for one and the same thing because it's all supposed to be quantum, right? So what do we do then? And so the main intuition that I think drives at least half of the quantum approaches, specifically all those that equate consciousness with the observer, is just to say, so we gotta have something that's not quantum, right? Now we're absolute reductionists in this debate about, material stuff. Everything your screen is basically made out of quantum objects. It's a quantum object. So what's the only thing that comes to mind? That's certainly not quantum, even if you're a diehard reductionist like this. And well, what comes to mind, and what did come to mind for John von Neumann in 1932, is just consciousness. Arguably, that is like, if it's this sort of thing. If I put a barrel at your face and force you to say something that's not quantum, not physics, not materialist, well,
Right.
then, if you don't want to say anything, you're going to probably say consciousness. And this also, to be fair, this drives much of the intuition about the hard problem to this day. We all have this intuition. Well, if there's a problem with materialism, then maybe it's because of consciousness.
Yeah.
And then this motivates this view. But if you look at what an observable is in the physical theory, what observation means in physics, that's something entirely different than consciousness, So you got to have good reasons to actually equate these two.
Could you maybe
And
just elaborate
Mhm.
on that? Because this has been, again, going back to Carlo Rovelli, probably
Yeah,
learning about these
yeah,
double slit experiments
mhm,
is probably some of the, again, those just
yeah,
like, how the hell does the world work like that?
yeah.
Explain a little bit about how you think about the observer and why the hell it seems to, on first intuition, it seems to be warping reality.
Mhm.
What is actually happening in your mind?
Okay, this is a
A little
huge
bit of a
topic, and
detour for
also
sure, but it's just always been
no,
interesting for me, and I'd love to
I'm
get your
happy.
perspective on it.
Yeah, I'm just trying to excuse myself for saying something very trivial in a second. This is a huge topic. It's very contemporary. There's debates right now what it takes to be an observer and what exactly that means. So here's my sort of like little hack to actually get around that question. So there's no observer in quantum theory, like in the theory that we've written down. They're just observables, right?
In the
There's
maths, in the form, in
Exactly.
the yeah,
There's a thing that's called observables. And so that's not an observer. And so observables they're a wonderful tool for physical theories. What they do is they take, let's say you have your whole room of like measurements set up. It's literally a room. It takes probably 5 PhD students to build it up. And now the theory gives you something wonderful. It now allows you to summarize what this whole room is doing in one simple mathematical object. It's called an operator, something like a matrix. And so that's amazing. And then you call this an observable because it represents the whole process of observation. And I can wrap my head around that, and I can make sense of that. And I know what this is. But now, when we discuss observers, we somehow want to find the essence of observation. So things become very complicated. We're asking questions that the theory not naturally poses. And I
yeah.
think these are good questions. Yeah.
Yeah, I've just never
Yeah.
been able to wrap my head around it, but I love
Yeah.
talking about it, and that's why I wanted to get your
Yeah.
idea. I guess the main train through this is that when I ask for an explanation for you, you're so mathematically grounded that it's
Yeah.
like,
Sorry. Yeah.
no, no, not at all. That's
Yeah.
exactly why I'm having this
Yeah.
conversation. And
Mm.
why I think we need to, again, what we were talking about earlier, sort of build
Yeah.
that
Yeah. Yeah.
communication language
Yeah.
between the two so we can
Yeah.
really optimize it. But
Yeah.
it's super interesting.
Can, can I add something really
Please.
small on the quantum part? Because I
Yeah,
think what I
please.
said now was really very negative, and I just also want to say something positive because I also truly believe that there's some good contribution that is possible in the quantum realm to consciousness science. And I have some unpublished results together with a friend and colleague again in Oxford, Kobi Kremnitzer. And these results point at the fact that sort of quantum theory gives us a very good sort of starting point to build a certain class of theories if we wanted to. And
Interesting.
and so I think that the whole quantum realm could be super important for the field, but right now we're just epistemically speaking, we're not in this very good situation. There's lots of prejudices on both sides. Some like on the quantum approaches, people typically think that all the non-quantum or the materialist reductive approaches they don't work at all. On the other side, we have people that think quantum approaches are completely nuts. And I think that also here the mathematical perspective can somehow bridge a little bit, and find out many of the approaches in the quantum concepts, they're driven by very good intuitions that people have about the quantum formalism, but they're not actually about the specific formalism we have in quantum theory.
Right.
Federico Faccini, for example, who was very knowledgeable in this space, I think his intuitions are about a certain structure of math that he sees in the
Yes.
quantum formalism, and so we could work these out. Yeah.
Yeah, I've watched a couple of interviews with
Mhm.
him. I really don't understand what
Mhm.
quantum fields being conscious means as a
Mhm.
sentence. I
Mhm.
am maybe you could, one of the
Mhm.
things that Hameroff rattles
Mhm.
on about is that these microtubules are capable of quantum superposition, and the
Mhm.
collapse of that is sort of what's creating the conscious percept in that moment. Are you
Mhm.
able to add any context to, like, some people say no, it's impossible, you can't get that quantum effect in such a warm, fuzzy
Mhm.
biological system? Do you have
Mhm.
any opinions on that? Do you think his explanation is plausible?
I don't think like so. I should say I'm not an expert on like microtubules, but I do
Yeah.
know that when you talk, I met Roger Penrose at an event earlier this year, and when you talk to him, he now keeps on saying, microtubules, I don't know about that so much. It's not my field of expertise, which is interesting because he's worked with Stewart for 30 years. So what I'm trying to say is,
Right.
let's look at the model independently of the microtubule assumption, and we can then add or not add this as we see fit.
Right.
And I think that I like regarding the justification, the standard justification of the model. I know Stewart quotes evidence that that is shocking if true about like how anesthetics works, and someone who has serious knowledge about this, which isn't me, should definitely look into this. This is definitely a good thing. But as far as the mathematics itself are concerned, there's this idea consciousness isn't computable. There's something non-computable going on. Therefore, we need to find some way of like bringing non-computability into the game. And there are people who've worked on this. My current state of the knowledge is like all of these questions, we have to be very careful about what does this even mean? What does it even mean to say that consciousness is non-computable?
I have no idea. I'm glad
yeah, I
someone
can tell you
else.
what I think, but it's
I
going
have
to be
no idea what
rabbit
that means.
yeah, and there, like I really admire Roger Penrose, and he has, of
Yes.
course, some great arguments to show you that he cannot understand certain things that a fixed machine. So the other way around, you can understand certain things that a fixed machine can't. And there's good work on like even like trying to get solid about these arguments. But even if we did, they're not about consciousness necessarily. There's some jump there. And then we can think about what does it mean to say that consciousness is non-computable? And non-computable is a property of a function from natural numbers to natural numbers. So what's the function we're discussing in the context of consciousness? Well, it's got to be a mathematical structure. Functions are structure. So which one is it? There's this can of worms you're opening, and I think at the end of the day, I'm, as a physicist, in physics, we are in this mode of science, which some people call hypothetical deductivism. It's basically a mode of science where we say, I'm fine with your theory. I don't mind. I don't know where it came from. I don't know. Did you smoke something? Did you have a good night in the bar? Or did you think about this for 10 years? Your theory is fine. Let's look at it. Let's look at the predictions. Let's look what it says, and let's take it at face value independently of the motivation. That's what we do in physics. And I'm tempted to always do this in consciousness, meaning for me, it's not a big problem if the motivation is a complete chaos. It's mostly, let's look at what you think is true. And I do think that every single theory that we have in consciousness science has been proposed for some good reasons. And the difficulty or the challenge is to find out what the good reason is.
Yes. Yeah, makes sense.
The Giant Shoulder mission is to explore radical ideas in biology, neuroscience, and consciousness, and elevate those stories to the highest possible level while keeping them accessible to everyone. If this interests you and you want to support independent science, then please consider subscribing to the Clips channel. Check out our 26 Neuroscience book. You can download it for free or get a beautiful physical copy, and check out these giant moments next. Thank you so much.